Okay, today I will introduce our project of design a continuous anomaly detection system applying unsupervised outlier detection in the procurement process. Me, Xiaoyu, Professor Aaron, and Professor Miklos are participants of this project. So the objective of this project is to introduce the design of a procurement anomaly detection system, which identifies various risky transactions on a continuous monitoring basis. Well, we focus on guide the companies how to use unsupervised outlier detection algorithms. Well, we still use rule-based and unsupervised learning method to overcome some limitation of the unsupervised outlier detection algorithms. I think the main contribution of our project is that this system can identify various types of risky transactions without sophisticated rules. And we know that using unsupervised outlier detection is new to the companies, and they really need some guidance on how they can really apply these systems, these algorithms. So we also believe that this method can be fit into the multi-dimensional audit data selection framework. Then we can improve the accuracy in the long run. Let's first have a quick review of the related literature on procurement anomaly detection method. We can find people already use supervised, rule-based, semi-supervised, and clustering method. However, we say that they all have different limitations. For supervised and semi-supervised learning method, we know that the companies should have sufficient past record. Well, if they use semi-supervised method, they may need as much data as they need in supervised learning. However, the label data should still be accurate and representative, and those are challenging. Well, some people use clustering to find similar transactions and put them into clusters. Then auditors can focus on the high-risk clusters. However, this will not give you directly risk level. You still need the auditors to make all the judgment by themselves. And the rule-based method is the most frequently used method. Sometimes we also call those rules red flags. Sometimes we call them fraud indicators. However, we need to really spend time to make sure those rules are very accurate and useful. So the problem here is that no existing literature really detects procurement anomaly with well-designed system, and we do not know how to overcome the limitation of unsupervised outlier detection algorithms. So here, when we say outliers, we mean that the observation deviates so much from the other observations. So we really suspect that it was generated by a different mechanism. So the advantage of use those outlier detection algorithms is very clear. We don't need complete accurate prior knowledge. So this is just very suitable for the procurement process because we know that the procurement process is not like, say, credit fraud behavior, because the client will eventually report those fraud behaviors. Then they can have the label data. But in procurement, if the auditors never do the investigation, it's possible that we will never know whether it's fraud, whether it's high risk, or it's just a normal transaction. That's why the application of outlier detection is super useful here. So if we try to summarize and say what's the advantage, we will say use outlier detection can help us build a model without sufficient and accurate past record, and then we can have a small sample, which auditors most frequently use to verify. And but we still have a problem here. The problem here is that what outlier detection identify is what we call outliers, and they are not necessarily high-risk transactions. I will introduce you what's the difference next. So before we introduce the risky and safe and outliers, we should say what's the problem, what's the limitation of directly using outlier detection algorithms. From input side, we can say there are a lot of noise because the noise in the data set can be misleading to the outlier detection algorithms, and those noise will be recognized as outliers. So we need a way to efficiently filter out those noise. From the output side, we know that we have risky and safe irregular activities, and they are all outliers. So let's try to distinguish the two concepts. The outliers are actually the observation which deviate so much from the outlier from other observations, and those are the output of the outlier detection algorithm. And what is risky transaction? Risky transactions are transactions that are harmful to the company, and those are the transactions that company want to identify. Of course, compared with normal transactions, they are all irregular activities. However, we should know that outliers contains high-risk transactions, risky transactions. However, they also contain safe but abnormal transactions. Therefore, we designed this system to try to overcome the limitation of the outlier detection, directly apply outlier detection algorithms. First, we can see that in the procurement transaction data, we have normal transactions, say the green point here, 1. And we also have outliers. We have 2, 3, 4, and 5. And among those outliers, we know that some are just irregular but safe ones, say 2 and 3. And for 4 and 5, they are actually the risky transaction we want to identify. So the first step is that we create this filter based on rule-based filters with professional judgment. And we also have a supervised learning filter with known cases. And we use this filter to filter out some known pattern of outliers. Some may be safe, some may be risky. So the outlier detection algorithm only works on those unknown cases. So we can make the model much more efficient. Then we keep the normal part in the outlier detection algorithms. And then we will put the outliers we identify for further verification. And then we can see that the auditors only need to give some professional investigation to the distinguished risky outliers and safe outliers. So here is the design of the framework, and the conclusion is that we believe this design is really helpful. On one hand, no one has really studied how to apply outlier detection to the procurement circle before, and we think the companies really need some knowledge from our academic side and to help them understand what are the considerations they should pay attention to when they try to use outlier detection. And we also believe that we contribute the continuous monitoring literature to better detect anomalies, and we contribute to the application of mass framework. And you can see that after we verify the result, we can use them to improve the rule-based filter and the supervised learning filters. So that's why we say in the long run, this system can be continuously improve the accuracy. And then we can make the most of the outlier detection algorithm. That's all. Thank you.
Thank you.